This is the third video in this series of A Quest for Pi. In the previous two, we looked at what pi is, with a very brief overview of how the first theoretical solution for approximating this number came to be. But for most, this seems a little arbitrary or redundant. I mean, most people probably wouldn't find enjoyment in using trigonometry to estimate a circle circumference, for example, especially with modern day computers that can print out pi for us in an instant. However, there is still fun to be had by the average person which also approximates this number. This video will look into how random choice from rolling a pair of dice can play a role in estimating pi. The mathematics behind this experiment are intensive and branches into areas which include the Riemann-Zeta function, the Basel problem, and random coprime probabilities. These topics are interesting and set the backbone for how this experiment pumps out pi, but it is not necessary to do this yourself. Instead, just take 2 dice and you're good to go. For this experiment, it's probably best to find dice with a larger number of faces, as opposed to the 6 that you'd usually see. This is because the more faces there are, the more precise the approximation will end up being. Rolling the pair of dice, note down the numbers, and check if they are coprime. That is, look at what divides both these numbers. Forgetting 1. Do they share any? 6 and 5 on the screen do not share any factors. Therefore, they are coprime. Repeating this for as many throws as possible and keeping score of how many pairs are found to be coprime and how many throws have been done in total, then the ingredients are there to find pi. Dividing the number of coprime throws by the total number of throws will estimate the probability that 2 random numbers are coprime. Then, pi is approximately equal to the square root of 6 divided by the probability. It's weird that pi ends up appearing in a real-life experiment that utilizes probabilities, and it being an experiment that everyone can do makes this number a little more fascinating for some. When I did this, I threw 2 dice, each with 120 faces, 532 times. It took me nearly 3 hours to do this, and doing the calculations with my results found pi to be roughly 3.096, and so on, which has an error of around 1.45%. For this relatively low number of rolls, this is an excellent result and comparable to using a dodecagon with Archimedes' method. However, your result may vary from this, because using a different number of rolls, a different number of dice faces, or just from the intrinsic nature of probabilities in general, the result for pi could change drastically. Next video will be a delve into another practical experiment, which is even more fun and a lot less efficient. So thanks for watching. I'll see you next time.